So here we are going to look at brand detection and image to text, one of the very important functionalities of AI, image to text. A lot of applications for image to text analysis. And this particular model, the Azure AI service is providing, as of now at least, very strong model. It was converting correctly almost everything I threw at it. Very bad handwritings, very bad captchas. It solves captchas as well. It just behaves better than a human in terms of image to text analysis. You can throw your own images at it, captchas and things like that, but it's a very, very strong model as far as I can see and as far as my tests are concerned. Without further introduction, let's get into it. So this is the example for brand detection. Again, another computer vision example, and we are going to use the computer vision client object. But this time it's a slightly different API. So I have commented out some of the complicated part of the code, which is not really making the point which we are trying to put it out here. So the code remains the same, just like before. The subscription key and everything is exactly same. The part which is different is probably these lines right here. So one of the difference we're having here is we are using a local image. Most of the APIs support local image as well, even in the previous examples. So I'm going to show you a local image in this case. This is a local image we are trying to use here, and we are opening that file. So this is the file we are opening right here and taking the file object out of it. And that file object is what we are passing to the API. So analyze image in stream. So before that we were using URL and we were passing a URL here. Instead of that, it is analyze image in stream. And one more thing we are passing is local image features. And this is the brands we are using. It's very similar to the ones we have seen before. For example, in the case of landmarks, we have seen similar things. I'm pretty sure it is the same model sitting behind. We are accessing in different ways. Now let's have a quick look at this particular image in our disk. So this is the folder in which that image is there, and it is this particular image we are going to look. I'll be giving all these images to you if you want to have a look. You can try other images as well if you want. So this is the image we are going to try, and I'm sure you're familiar with the type of the brand in this particular image. Let's see if you're able to figure that out from the code. And this is the result which is coming here, and we are printing it out. Again, it is having a complicated print logic here. I'm not getting into it. I'm going to put a breakpoint and we will look at the object like we always do. So I'm going to start debugging. So we have got the result of the API, analyze image in stream, and this is the result. Let me close all these things and add this to the watch. So this is what we have got, and again removing all the underscore. There is no tag, there is a request ID, and there is objects none. Most of the things are none other than the metadata. If you want to view the metadata, this is the metadata of the image which passed to the model. There are a couple of things you can find out: the categories, color, description, phases, image type. None of those things we have passed. Probably we can pass all those things in here and we get something out of it. You can try all those options. That's why I'm showing you this particular way of watching. So in this case, we have passed brands, which is what is here, and we're getting this particular array. There is one brand inside the image, and that is Apple. The brand name is Apple. We knew it already, and it has pretty high confidence, which is 0.09, 90% confidence. It has almost 91% confidence, which is pretty high. So that's what we are printing here. Nothing special about it. So as you can see, we opened a local image, and this is the stream or the object, the Python file object we are passing to the API. That's one of the difference we are doing here. And feel free to try with other things here, which is mentioned in here: color, description, phases, image type, and things like that. Like I said, that's why we are using the watch window to see what options are available. Before we go to the next example, let's have a quick look at the documentation of this. So computer vision, analyze image in stream, API version 3.2. So mostly when we create this particular object right here, computer vision client, we are accessing the 3.2 version of the API, and the first example we have seen is the 4.0 version. So this is the operation it performs. If I click on this, we'll get some more examples and so many parameters and things like that. And this is a sample response, landmarks, object, color, phases, a lot of things it gives. Feel free to try out. So we have the brand in our example, and we got Apple here, and the confidence level we have seen, and this rectangle. Rectangle is where exactly in the image this brand is appearing. So it is there in our result as well. So if you click on the brand, click on the item, so we got the confidence level and the name, and here is the rectangle object. So we are paying attention to all the non-underscored things inside here, except this special variables and function variables. I wish there was a way to hide these things in Visual Studio Code. At least I don't know any as of now, because those are just internal things. Only 3 things matters to us. In fact, 4 things. Additional properties, if you want, you can have a look, but we don't have much. The rectangle is right here, like so, what we are seeing in the documentation. So pay attention to the watch window of the returned object as well as the documentation. They go hand in hand, especially the return sample return response from the API. This gives us a lot of information. So there is interesting categories of people and details. It is detecting celebrities and things like that. You can give a picture of Satya Nadella and see if it is detecting. Looks like it is, with a very high confidence. So give different images and try your luck and look at the documentation. There is a lot of documentation about it. Feel free to go through it. So next item or next function I would like to focus is describe image. Again, we are giving a URL to the image and describing the image. We have seen very similar examples, but in this case we are exploring this particular API of the computer vision client. Another API we are calling is tag image. So we'll have a look at both of the output. So we'll just call the API with this particular URL and we'll see the result. So I have a breakpoint here and I'm going to run it, start debugging. Everything else remains the same. That's why I'm not going into it. It's all same object, same client, everything same. It's just the different API we are calling, or different SDK function we are calling. So in this case, it is describe image. Let's have a look at the image. So this is the image we are going to look. It is from the Universe NASA Rails. Some image it is there. It is the image of a black hole. So this is a black hole. I really doubt the image detection mechanism. The model is trained to tell you what it is. I know this is a black hole because I follow astrophysics and things like that, but I doubt our model is able to do that. Let's have a look anyway. Probably it may surprise us. So we got a successful result, and let's have a quick look. Let me close this so that we can observe the new one. I'm adding to the watch the result. There is a tag and caption. So this is what we are going to look at. Caption is there. There is no additional properties. It is empty. So let's look at the caption. So there is one caption right here, length equal to 1, and it says a red and black glowing object. So it is seeing a red and black glowing object. It doesn't know that it's a black hole or anything like that. It is given a very generic explanation. Probably if you ask this image, if you show this image to a kid of 12 or 13-year-old, it may give you the same explanation. And the confidence level, as you can see, it's pretty low. It is not really sure that this is the thing it is talking about. The confidence level is very low, 0.25%. So it is not sure. It is very generic information it's giving. So like I mentioned, AI is exactly like this. I wanted to show you this kind of non-functioning examples as well. It's not a very functioning example we are looking at. The confidence level is pretty low. And we got a tag as well called blur inside the tag option. But anyway, the result is kind of negative. It is not able to detect that it is a black hole because it is not trained to recognize black holes. Let's keep going. We are going to call another API called tag image. Let's see what it is going to give for the black hole image we are having. So it is pretty complicated image we are having. black hole itself is a very complicated object. Probably the single most complicated object in the universe is a black hole. It's a totally different story altogether. So we are going to call the next API, which is the tag image. So we got the response. So this is the response on the previous. Let me close that response. Let's add this response. I have skipped all the printing lines because that's not really important to us. It's just looking at the same thing. We've been looking at the watch window. Watch window is more descriptive. That's why we are using the watch window. In this case, we have the tags. We're focusing on the tags. So we have a couple of tags. We have almost 6 tags in this example. So let's look at one by one. So it is saying that it is an art. It's a generic art with pretty high confidence. I wouldn't disagree with it because it is in fact an artist rendering of a black hole. Normally, we don't have this kind of close-up image of black hole as of now. So it is an art. No question about it. Let's see what it is. Amber. Not really sure what it means. With 85-90% confidence, it's saying orange. Yeah, the image is having orange hint in it or color in it. 86%. Lamp looks like a lamp. Light, low confidence. And abstract, 50%. So I clearly assume that this particular model we are using is not trained on astrophysics. It doesn't have the astrophysical images it is trained on. So it is trying to give you a guess of what it is, but it's not really sure what's going on. And we are printing it out. But feel free to give some simple images and test it out. I was giving the model a hard time by giving black hole image to test some extreme cases and things like that, but give some simple image like a boy kicking a football or something like that. Simple image and see what it says. It should give you better examples. So that is image description and tagging. So next is OCR. OCR we have seen in the case of content moderation and other models. OCR is very common use case. Character recognition, that is OCR. Finding out text from images, very important use case when it comes to image analysis. Probably one of the most used image recognition, perhaps one of the most used image recognition algorithm. Again, this part of the code remains exactly same, no difference. And this is the object we are going to analyze here, or the image. So let's have a look at the image. So it is an image of a person teaching something, and there are small text here. If you want, you can zoom it out. So 9:35 a.m. conference room, then a number and things like that, and a couple of small text and things like that. We are going to see if we can recognize all these things. It's a very complicated image in terms of text analysis. Let's see how much our model can get it. So the function we are going to use is a read. And in this case, we are passing the URL and a row equal to true. We can check the documentation to understand what row equal to true means. So the documentation will have explanation on what row equal to false, for example. So I'm going to put a breakpoint here. In this case, the flow of the API is slightly different, and we are using a loop here to get all the text out of the image. First, we are calling the read API from the computer vision client, and then read response. And we are taking out this particular thing out of the read response, and we are creating this particular object right here. And then we take something called operation ID, and using the operation ID, we are calling another function from it. So slightly different workflow from the previous attempts we've been doing. So let's have a look. So I'm going to start debugging. We have a breakpoint here in line number 37. Now let's have a look at what object we got from this API right here. We have given the image to that API, and we need to understand what it is giving us. So read response. So I'm going to add it to the watch, and let me close these ones. So read response is here. Let's see if it is of any use. Again, we are going to ignore this too. And of course, the underscore. So what we have something called header and something called response. Response code is just the normal API response code. We got a 202. If you don't know what this 202 means, refer to HTTP response code 200 and something start with 200, 201, 202. All those things are success. So something success happened. And in headers, another thing is header. The other thing is output, which is empty. Header, inside header, again, we are going to ignore this too. And we're going to focus on this. All we have is something called operation location. Let's have a look at this operation location. As you can see, it is a URL. It's another API endpoint within the API we are calling, within the object, within the endpoint. So we 3.2 read, analyze a result, and then a GUID after that. So that is the operation location we have got. And now what we are going to do, we are going to call another API with that information within this read operation location. And in this case, we are taking that ID, that GUID we have seen in the end of that URL. So let's take the URL first. So here we are taking that URL here in this variable. So we call it the URL, and this is a Python statement which takes that ID in the end, split with slash the entire string, and take the extreme end. That is, this -1 is for if you have any kind of confusion, refer to any Python document or try some small examples and things like that. Refer to my previous training. It's all Python magics. And that's exactly what we got, that ID, which is nothing but the end of this particular string. So we split that string with a slash and took the last element of that split. That's what we have done. And we are having an infinite loop here, although the loop is going to run only once or twice. In this case, we are going to call the API, and this is the read result. This is going to be interesting to us. So add to watch again. Let's see what we are going to get here. So we have a status here. Status is succeeded, which means that we are going to break it here. This line is going to break, which means that we are going to execute this loop only once. I'll tell you why the API is designed in this particular way shortly. Hopefully I won't forget that part. For the time being, let's focus on what we are going to do. So it's going to break here, like I mentioned, because the status is succeed. And we are saying here, if read result dot status not in one of these things, break. Succeed is not in one of these things, so we are going to break. This is what I love about Python. This is like a English statement. If read result not in this, do this. Very much like English. Now, what we got. So we are going to exit the loop, but we need to understand what we got. So what is interesting here is the status as well as something called analyze result. Everything else is pretty much empty. Inside analyze result, we have again all the metadata version and things like that. Then the read result. Feel free to look at other things. I'm just clicking inside, and we have something called lines. If you want, you can look at other things. Here are the lines. There are 16 lines inside that, and the first line, if you look, it is one of those strings within that image. So if you look at the other things, it is the next line and subsequent text within that image, town hall and things like that. It is all from that image. If you want, you can have a look and verify the accuracy. And it is giving the bounding box and other details about it, pretty accurately describing a lot of things. And this is just printing that out here. If I want, I can put a breakpoint here and then give it a go and see the print result right here. Pretty much, I guess it is all from that image. If you want, you can verify later. Now, the reason why this is done in two APIs is, I believe, in some cases there are a lot of text, and this kind of operation is good for paging. If there is a lot of text in the image, it is good to give page by page so that you will get a partial result initially, and subsequent calls you can get the full result. Basically, for performance reasons and scale reasons, this kind of APIs are designed like this. That's why we didn't get the full result in here. So it is like a design choice by the designers of the API, which makes sense in the case of long text. So the next example is also OCR, but in this case, we are reading from a local image. Like I mentioned, most of the services we have seen in computer vision so far can be used with URL as well as local image. So in this case, we are going to use a local image. This is the image we are going to use. Other than that, the code is exactly same as the one we have seen so far. So let's have a quick look at this image, handwritten notes. So this is the handwritten notes, and both the images are pretty similar. Let's see the one we are using, _1, and that is this image. Let's have a look at that image. So this is the image we are going to look at. It is some handwritten notes. It is actually a formula for calculating some of the failure chances of models. But for the time being, let's focus on what the text is and check if you're getting it right. It's a pretty complicated example. Looks almost like a CAPTCHA for me. Handwritten notes, a lot of different fonts and stuff. Handwritten image to text conversion is one of the most complicated type of OCR. Let's have a look. So I'm going to start debugging. The breakpoint is again in that operation ID thingy. In this case, we are going for read in stream. Stream means local file, almost always local image. Just we have opened that image like before. If you have any questions and confusions, which means that you're new to Python, it's all Python stuff, feel free to refer to my Python training. So this is the handwritten image right here, and the response is exactly same. We are getting that operation location with a different ID this time. Every time you should get a different ID, hopefully. And we are going to do the exact same thing, pretty much same code, copy and paste. Only two differences. One is local file and it is handwritten. More complicated example. So let's see what we got in the result. I'm going to add the result to the watch. So if you're giving the file location, make sure that this file location is correct and readable to the program. Otherwise it won't work. You will get all kind of errors. So analyze result. I'm going to click inside without much explanation. Object inside object. That's what it's all about. We got the lines here and F1-2TP. F1 equal to 2TP. It is taking it as hyphen because it's very unclear. If you look, it's not very clear. If you look, it is not very clear. At the moment, it is at 800% zoom. So hyphen or equal to even, I'm not able to figure it out. So it is F1-2P. That is a success. Let's see what is the next line says. Recall. Recall it right here. And 2TP plus FNP. Yeah, it is putting this thing there. 2TP plus FN plus FP. Yeah, it is doing a pretty good job. It is even figuring out the text in the end. There's a P right here. Definitely a good job when it comes to handwriting recognition. True plus positive rate. Yeah, it is exactly true. Yeah, it is doing a pretty accurate job. Let's have a look at the bottom one. Example, fraud detection and sensitivity. Yeah, pretty accurate. This model is definitely doing its job, and I would recommend this model for any kind of complicated production workloads. I'm pretty sure this model will recognize captchas and solve captchas and things like that. You can try it yourself. Some models has specific moderation for captcha. It doesn't solve captcha on purpose. I don't know about this. I have not tried, but all in all, this model should be solving captchas. So like I mentioned, a lot of this AI models has security implications because captchas are purposefully designed to avoid bots. But these kind of models can circumvent captchas. In fact, in some cases, it is illegal to circumvent captchas. So that's where the gate's coming in. Fortunately, this particular model is not gated, but that's where the gate's coming from, the legal part of certain things these models can do. We are not supposed to do such things with the models. So that is about OCR. We have seen two examples, and before we go, I want to see one example where it is not going to work and we are going to get a specific error for this particular example. This is where the gates I'm talking about, and we will see that. I'm not going into the example in too detail because it is not going to work because of a specific reason. So analyze image by domain. We have seen that before. In this case, we are going with celebrities and we are going to pass an image of a celebrity. Doesn't matter what this image is going to be. We are not going to waste our time looking into it. But what we are going to do is we are going to put a breakpoint right here and execute and see the error for ourselves. So we got this error like we were expecting. So we are interested in the error and we are going to read out the error. So the error is the computer vision error response exception. Invalid request. Feature is not supported. Please apply for access, and there is a URL. So this is a gated feature we are trying to access. We need to go to this particular place To request access, we need to give a proper reason why we need to recognize celebrity faces and things like that. Like I mentioned before, in the case of CAPTCHA, these models can be misused. I can't think right now a reason why this is gated, but I'm sure there is. There is way these things can be misused. That's why this is a gated feature. So there will be human intervention in this. So people will be looking at your request. Mostly they will reject without a proper business impact statement. They may reject the request. For example, for training purposes, this is not allowed. That's why we got this particular error. So we have seen brand detection and a couple of other things along with image to text. As I mentioned, very strong model, and we are going to discuss other topics in the next lesson. Thank you.